Hey, this is Sanyam Bhutani, and you're listening to Chai Time Data Science, a podcast for data science enthusiasts where I interview practitioners, researchers, and Kagglers about their journey, experience, and talk all things about data science. Hello and welcome to another episode of the Chai Time Data Science Show. In this episode, I interview Andres Torrubia, who is an entrepreneur at the intersection of engineering, customer first mindset, and monetization, and also a Kaggle Competitions Master and active Kaggler. Andres has co-founded a digital distribution startup headquartered in San Francisco, which sold for 34 million US dollars. And he's currently the CEO and co-founder of Fixer.com, spelled Fixr.com. Fixer.com is helping owners make the best decisions on their home. So do check out the website if you're interested. Andres has a Bruce Wayne during the day lifestyle where he works on his companies, and a Batman during the night lifestyle during which he works on Kaggle competitions where he's an active competitor. In this interview, we talk all about his journey into the field of data science and Kaggle. We also discuss the predicting molecular property Kaggle competition by Champs, where Andres' team, Quantum Uncertainty, was placed second in the leaderboard. And this also pushed Andres into the Kaggle Competition Master tier. I'd also like to thank everyone who submitted their questions on Kaggle forums for the AMA section, and to Andres, of course, who was kind enough to answer all of them. For now, here's my interview with Andres Torrubia, Bruce Wayne during the day and Batman of Kaggle world at the night. Please enjoy the show. Hello everyone, I'm on the call with Andres Torrubia. Andres, thank you so much for joining me today, and especially for agreeing to the AMA section of the conversation.
Yeah, thank you so much. It's my pleasure to be in this podcast.
So you've been working in the business world for almost 2 decades now, if I may. You've co-founded a company that got acquired for 34 million US dollars and are currently the CEO of Fixer.com. Before we talk about your quote-unquote Bruce Wayne life, can we talk, how did you become Batman? So you have this title, you're Bruce Wayne in the night and Batman during the evening, machine learning in the evening. Could you tell us about your machine learning journey and your deep learning journey? How did you get started?
Yes, actually, so my background, even though, I'm now a CEO of Fixer, my background is really as an engineer. So I think my only job, and we'll touch on this later, was at CERN, at the European Center for Nuclear Research, where I was an engineer for about 1 year. Then so I have a background on software development. What now, in the deep learning, machine learning community is referred to as software 1.0. Mm-hmm. So basically what happened is one day I would just, as a regular user, open Facebook and Google and things and see that the computers started recognizing faces. So I started seeing this trend, especially about perception, which I thought as an engineer that was out of reach. It's been out of reach for those 2 decades. So I started feeling like this fear of becoming obsolete. Like, if you are, let's say like you are chemical engineer and you see a spaceship going out to the moon or even to the to the solar system. So you can think about the reactions that happen, the chemical reactions or the propulsion systems. So you would understand that now if suddenly some extraterrestrial alien comes in from another galaxy, you have no idea of how it works, right? So I felt the same, like, oh my God, I'm an engineer and I have no idea on how this technology works. So then just out of pure intellectual curiosity, I joined one online course. In this case was Udacity. I joined the self-driving nano degree. And the reason
Interesting.
for choosing the self-driving is because I thought that was a very difficult challenge to do a self-driving car, and that for sure we will have to use techniques that were unknown to me. And of course, at the core center of those techniques, which I didn't really know at the time,
Yeah,
was machine learning, but especially as the course progressed, deep learning.
got it.
That was triggered my journey.
Okay. So also to talk about your journey in the business world, you've been working in business right after graduation. You did work for CERN for a while, but you have a portfolio of having advised, co-founded, and even worked as a CTO, and now as a CEO of a business. What made you pick this path as well, and why not go along the job path?
So I would say that it's been very personal. So, I started coding when I was maybe 14,
Well,
15. And I'm for the most part, self-learning. I live in a, relatively sized city, but it's 300,000 people in
mhm,
Spain. So I didn't really have lots of, community, in person around me. So I have to learn, you know, basically through books, etc. I have some colleagues, but less that I would really have liked. So then, what happened on those years before even university and during university, I had all these ideas, and it was funny because I had this idea, maybe very simple, maybe even a game, etc. But then, maybe 1 year down the road, I would see it in a product.
mhm.
So then I said, okay, I have these ideas, and more often than not, I see them reflected that somebody else is doing it. And then
Yeah.
then very clearly, very early on, I said, okay, eventually I will be, creating those ideas and trying to put them in the marketplace. My original plan was to work for a few companies,
Mhm.
CERN and maybe other companies. Back then, I really liked cryptography. So my original plan was to work, first in CERN, but then pick a different companies. But
Mhm.
then, I visited the US. My cousin was there, and then I told him about a few ideas I had back then,
Mhm.
and then basically I quit CERN while I was visiting my
Okay.
cousin.
Interesting.
So yeah, it was very. So I think I really had all this like really original plan of start a company.
Mhm.
So I knew I would do it eventually, and basically I did it before that original plan. But I think in retrospect it was good.
Got it. Coming to your current job as the CEO of Fixer.com, could you tell us more about the business and what parts of it do you handle?
Yeah. So Fixer is um, the place where you go to make the best decisions about remodeling.
Mhm.
So we run the site in the US, and now we've just launched Spain. So you want to know how much does it cost to paint a room,
Mhm.
etc. So we have great content. And then if you make the decision of okay, I'm going to go ahead and build this project and do this project, then we can hook you up with local companies in your area that can give you estimates. That's what we do. And as you are thinking right now, it's very detached, right,
Yeah,
from machine learning, etc. So we'll get into
totally.
that later. So
Mhm.
as a CEO, I do what, um, uh, you know, um, from there's few things CEOs have to do. High level, is finance, setting the strategy, and then making sure hiring we have the best talent that we can.
Mhm.
So I do those three things. Luckily, the company is doing well, so we don't need financing. We've been, in the business for 10 years, so it's
That's
it's
great to
more
know.
than enough. So so on that front is good. And then the new thing that I'm doing, and it's a consequence of this machine learning journey, is so before, as I said, I started this journey for intellectual curiosity. So it was
Mhm.
not about, okay, I want to study deep learning because I want to apply it in my business. So it
Right.
was not the case of a solution looking for a problem, which
It
sometimes you
was
see,
just out of curiosity for you.
curiosity. And then what has happened down the road is I started feeling like a hammer that only see, what's the name? Nails, right? So
Yeah.
it's I'm like a so every place I look in the business, I have again a software 1.0 background. Also, I see, okay, why don't we do this with a prediction component instead of having this old style rules to drive
Yeah.
this process. So then suddenly everywhere I look, I see things that we can approach through machine learning. Some and more often than not, I try to do deep learning, which will come later.
Got it. So now there's a question from Alison Davy. It's Could you tell us what made you sign up for your first competition? We did have a
Oh
very
yes.
interesting conversation offline as well.
Yeah, sorry. Um, so yeah, that was super fun. So what happened is, so say I joined the Udacity nano degree, and then there's initial term, which is 3 months, and on
Mhm.
those 3 months there's just I think one or maybe two. There's two exercises, two projects. One is the traffic sign recognition, so it's very simple, if you will,
Yeah.
just classification task,
Mhm.
classification only. It's not detection. So it's very simple. We did it in TensorFlow, etc. And then the second project was a behavioral cloning project, where
Mhm.
you have to, you know, drive in a video game kind of thing,
Yeah.
train a neural network to predict the steering angle, right?
Mhm.
So with those two projects, remember, I come from nothing, right?
Yeah.
Not having no idea of machine learning, and 3 months down this path, I've learned to implement, neural network, which for me was a huge deal back then. Then I felt like I had superpowers. Okay, so what happened is right after I finished the first term, okay,
Yeah.
3 months, then Udacity and Didi, it's like the Chinese Uber, they
Yeah.
launched this competition
Mhm.
about is basically you have to build a real time
Mhm.
um, detector of pedestrians and cars.
Okay.
And so the inputs are really all of the sensors that are supposed to be in the DD car, which
Right.
is a cheap LiDAR. It was only, if I recall correctly, 32 channels
Mhm.
LiDAR. So the channels are really the lasers. So there's
Okay.
the LiDAR basically, for those that don't know, is the sensor, this kind of ugly sensors that are on top of the car, right? Very
Yeah.
expensive.
For sure.
Some of them more than the actual car.
For sure.
And then they have lasers mounted like this, okay,
Yeah.
that spin in a circle. And then the lasers record the distance that the light travels and reflects back. So
Mhm.
you have, and then you, it's spinning, maybe it spins um, 10, 10 or 20 times per second, if I recall correctly. 10, this case was 10
Mhm.
times per second. And
Right.
then you get, for each um, for each spin, you get a point cloud. So it's all
Okay.
these like black images with points. It's kind of like Matrix, the movie.
Mhm.
That's the LiDAR reading. So you get, in this competition, you got the LiDAR reading of a car like that is going, around. And
Mhm.
then you also get cameras. The car has a camera, and you get some of the sensors that you're not going to use, like the gas you have left, etc.
Mhm.
So this competition was about getting all those sensors, as many as you can, or as few as you can,
Right.
and then predict, like putting a bounding box in 3D,
Mhm.
um, the obstacles. Now,
Got it.
what happens is something that in the literature, which I didn't know at the time, is called the Moravec paradox, which
Yeah.
is things that for humans seem super simple, but are difficult for computers. So what happened to me was the perfect storm between the Moravec paradox
Mhm.
and my overconfidence of just having finished 3 months of this journey.
But
Of
to
so then I
emphasize,
felt,
you also worked in the software domain for like before jumping into the machine learning domain. You had been active there.
yeah. So I think I think I had a good start in programming, although I didn't know any Python back then. But Python is a very benign language
Yeah.
compared to C or even assembly language, which was my origins in assembly
Okay.
language. So you can imagine. Then also decent math, from university,
Mhm.
from my studies, and then also systems like building a computer, running Linux. So all these three things,
Yeah.
which are, I think, prerequisites, I already had. So
Got
that's
it.
a good start.
Okay.
So then, but then in machine learning, but then what happened is, okay, this looks easy, right? Like if you look at the point cloud, you can actually kind of see where the car is.
Mhm.
and I know how to build neural networks, so this is a piece of cake. It was not a piece of cake. So what happened is my first so I joined this competition. The ground truth, as usually happens, was a nightmare. I spent lots of time cleaning the ground truth, and
Mhm.
then I studied papers, and it's very funny. So they were like two cutoff. They were like 2,000 teams, and
Right.
the first stage was to get just 50 teams out of the 200. So
Okay.
I found it was very new back then, very, very new.
Mhm.
This paper about that was, I think, as far as I know, the first paper that dealt with point clouds natively.
Mhm.
So in deep learning and machine learning, things are easy, quote, they're never easy, but easier when the data has always the same length, right? It's a structure. So for images, it's like a dense matrix of pixels that
Mhm.
you fit in, and always they don't change, right? But a point
Uh,
cloud is different, right? A point
Sorry to
cloud,
interrupt you. So, could you, for the audience who don't understand, what is a point cloud? Could you explain that?
yeah, so a point cloud is just like a set
Mhm.
of 3D points
A
in
3D
space.
image of a, if we may, gathered from a LiDAR sensor.
Yeah, but it's not an image. So the each item in this set are like at a minimum three coordinates, like X,
Mhm.
Y, and Z,
So, a
depending on your.
3D sort of graph situation from which we can generate an image of objects.
Yeah, you could project exactly. You could project the point cloud, which is what you are shown a point cloud.
Mhm.
You are really looking at a 2D projection
Right.
of the point cloud from the perspective of the car or from top of the car from one side, right? So that's a 2D projection, but the native point cloud is really a set of points. And the difficult thing here is it's a set of points. So the order doesn't really matter, right? So if you had
Mhm.
the order in which it appears in your array, let's say,
Yeah.
in computing, right? It doesn't really matter
Mhm.
because each point has its coordinates. So that's, you can start to see that that's difficult, right? For machine learning
Yeah.
to deal with, a set
Mhm.
instead of an array, right? In which the order matters,
Mhm.
or a sequence in which the order matters. So in this case, it doesn't really matter.
Got
And
it.
then also, it was difficult because each spin had a different number of points.
Mhm.
So that was also difficult. So,
Okay.
but then I found out this paper that was the first one, as far as I know, that dealt with point clouds natively,
Mhm.
which is called PointNet,
Okay.
from a team in Stanford. So
Mhm.
I implemented it, and with thanks to this implementation, I managed to get in the 50 in the first stage, 50th stage. But then, so as you know, I only had like one computer. I was a GPU, it was decent, but just one GPU, and
Okay.
they had lots of data in this competition. So I got an error of like a meter, which it was enough to get me in the 50 cut,
Right.
the first stage. And I thought initially that it was just a matter of, okay, the machine learning algorithm or deep learning hasn't really converged enough, right? So for me, this is going to be easy. I'm just going to rest and
Train
letting
it
the
for
computer do
longer.
its job, right? But
Yeah.
then one day I was running and I was obsessed with this problem, and I was like in my mind reviewing the paper, and then I thought about a few assumptions that they make in the paper that didn't really match the exact problem of that I was dealing with.
Mhm.
And then I emailed the author and I said, hey, is this right, what I'm thinking? And he said, yeah, that's right, which meant that all my stuff was not going really to get me any farther. So I had a crisis back then.
Okay.
It's funny because the same has kind of happened with this molecular competition. I will get into that later.
Sure.
Then I have to like rethink everything. And then, long story short, instead of looking at LiDAR as 2D images, which is what most people do, they
Mhm.
build projections of LiDAR.
Right.
Some like planar projections, like from the top, from the sides. Other like they do a spherical projection or cylinder projections. Um, but then I said, okay, if all these teams, and they were teams from universities, from companies, are really focusing on 2D projections, that's a path I cannot take, or that path I should not take, because
Right.
these guys are experts in this thing, and there's only 3 weeks left. And then I have to really stretch my mind, and then I consider the
What was the
lidars.
total duration of the competition? So, from when you entered, how
It was
far
like
away was?
3 months. and
Okay.
I actually entered like 1 month later.
Okay.
Um, so
So
it
two
was like
months for
I
you.
lost, yeah, I lost 1 month. So I thought, okay, LiDAR is really, if you think about it, a 1D signal,
Mhm.
each beam, right, of LiDAR. So
Yep.
basically what I did is consider LiDAR as a sequence, right, as it's moving, right? And then if it's a sequence, you could work with RNNs, right, or STNs.
Hmm.
So then I built, a point segmentation algorithm treating the LiDAR 16 beams as like a 16-dimensional 1D signal,
Okay.
if you will. And that really worked really, really well.
Mhm.
There were some issues in real time because, but then you don't really need because it was like very long sequence, like 1024, to not lose like angular resolution. But
Right.
then I was able to segment. So long story short, then I had the very few, like 2 weeks before the deadline, I partnered with a Russian teammate
Hmm.
that had a really good experience in the tool that they wanted us to write the solution, which is called ROS, Robot Operating System,
Right.
which he had no idea back then.
Okay.
So we kind of split. I was working on deep learning, the perception stuff, and he did the what is called the Kalman filter plus the
Mhm.
ROS implementation, and we ended up four in this competition. So that was
Wow.
I kind of felt a bit spoiled because it was my first competition, and we managed to do it, pretty decently because all the other teams have lots of previous experience. Like there was one Russian team that has been working for like 1 or 2 years in a Formula
Interesting.
One autonomous car, and
Okay.
the other guys all were Chinese from top universities in China. So I think I felt really proud to finish in my first competition in the first spot.
Got it. So, after getting the fourth position in that competition, how did Kaggle come into the picture for you? When did you sign up for Kaggle, and what was the point leading up to that?
I think I think I did this one, which happened. Yeah, I think I did this one, which ended in maybe June or May 2017,
Hmm.
and then it was a summer. I didn't do much, and then I joined my first one in Kaggle, which, if I recall correctly, was the Carvana one. Carvana competition was about, they give you a picture of a car in a
Right.
special setup that they had, and you have to basically do in Photoshop what is called the magic wand, right? To basically do a segmentation of the car, so getting the pixels of the car and only the car and not the background. So that was the
Okay.
Carvana one, which is image segmentation, which is conceptually much easier than
Hmm.
the LiDAR one. So this is my first image thing, which is not classification. I've never done segmentation. The challenge in this competition was that the images were quite big
Hmm.
compared to back then. So it was like 1080p images.
Right.
So it was an issue to fit them in the GPU.
Hmm.
So, and I always so that's when Kaggle came into place, and that was like, then I thought, okay, maybe if this, like with a unit, right, it looks like a solved problem,
Right.
which for many problems it is, image segmentation, as long as you have good data set. But
Hmm.
then I started, I opened this Pandora's box of things that are beyond just the implementation, like how do you augment data, and
Right.
crazy techniques were being done in Kaggle. Like, was looking at the forum. Then ensembles, I have no idea what an ensemble was, right? So then there's all these very creative solutions, sometimes maybe not so creative when you just blend examples kind of blindly, but still. So that kind of said, and then the community, right? The community in Kaggle, and the sophistication, like having the training set, the public leaderboard and the private leaderboard. Not many competitions have. So sometimes you join a competition that
Right.
is organized by a company,
Hmm.
and they do not have this level of sophistication. So
Right.
I really liked the sophistication, and also the competition, and also the fact that you could team up with different people,
Hmm.
not for the sake of winning. So I must admit that in the first one, I did it out of necessity,
Okay.
because 2 weeks left and I had no idea of Ross.
Hmm.
So that was kind of a necessity call. But
Right.
then on Kaggle, it's a great opportunity to learn from people that think very differently, that you think have different experience. That experience may be about coding, maybe about data cleaning, maybe about tools,
Mhm.
maybe about tricks. So it's I think a very rich ecosystem.
Got it. And for context, this was your second competition, so nothing happened between these two competitions.
So what could have happened?
Okay.
Uh,
Yeah.
yeah.
But did you take any other online courses or any other technique?
Oh, well, yeah, well, of course, I became hooked to this. So I did the Udacity one, but then I immediately saw um, the classes of 2016
Hmm.
that were taught, um, by three, I think minimum three. I think Lele, Andrew Karpathy, and then Justin Johnson, if I recall correctly.
Right.
I think it's CS.
Two, three, one, N, I think.
231 and exactly.
Right.
So, and that's a superstar class.
Mhm.
I think anybody worth their while in deep learning should watch that. Although it's labeled as image, they go
Right.
beyond image. So then I became completely hooked on, I watched this, reading videos, etc. So I didn't have any back then. Then after that, I did fast AI courses. But back then, so this is before fast AI 2.0. So
Mhm.
everything of my coding was done in Keras back then. TensorFlow was a bit too cumbersome for me.
Yeah.
Like raw TensorFlow, maybe good for research, but for practicality competitions, Keras fit the bill quite nicely. So that was my transition. So it was really Keras, watching just watching videos, reading
Mhm.
papers, and then also starting like to follow people on Twitter. I think we are lucky in this industry, if you will, or in this discipline or industry,
The
that
community.
yeah, well, I think we are one of the very few disciplines that happens to have like a real time open dialogue about the breakthroughs. So
For sure.
somebody will implement, like you see last week or 2 weeks ago with the optimizers. I had this joke like every day a new optimizer. So you used to have Adam, now you have like a rectified Adam.
Yeah.
Then people started also, like the day before came look ahead. People combine those two, and those all on the course of 1 week.
Yeah.
Right? That's crazy. In other disciplines, this may take months before you start, because we have archive for open papers. So I think that was like okay. So I was feeling that you are witnessing like the birth of a new thing, like when I was witnessing almost like the birth of the internet when I studied. So I was like, here is better because you can see things, and the time from idea, some from paper to implementation to production is super short. I think it's the
Yeah.
shortest I've ever seen.
Definitely. So the next question is from the king of Kaggle kernels, Artgore or Andrei Lukianenko. How do you balance time spent on competitions with life and work? So do you not sleep like Batman either? So you're Bruce Wayne in the day and Batman during night?
So mostly in the day, it's just like a regular job. I think and I will touch on this later. I typically join, for the most part, competitions where I can apply deep learning instead of conventional feature engineering, machine learning,
Hmm.
because I think the trend, there's few reasons. One is like practical. The direction in which society is going is to generate more and more data. So
Yeah.
even though in some scenarios less data, maybe like boosting algorithms may work better,
Hmm.
right? That's not really the trend we are going. We are going towards a society with generate more data, labeling is easier, etc. So that's one thing. Um, and then the other, from my personal perspective, is that typically the way in which I work is, you look at the problem in Kaggle, and then you see, you think in your head, how would you tackle it? And this is just like background thinking.
Hmm.
Um, and then the coding, as opposed to, so the coding in software 2.0, deep learning, machine learning,
Yeah.
is much, much shorter than in software 1.0. In 1.0, This has changed. But traditionally, like if you wanted to do like a conceptually simple website, it's always weeks, right, of
Yeah.
coding, if not months, right,
Yeah.
and a team, right. And now that we have full stack, but before you used to have like a front end, back end,
Yeah.
so it's crazy, like for a freaking website. Okay, so now this is like you have the idea, and if the idea is right, and with all these frameworks, we don't have to do the differentiation of the loss function is automatically done for you. So, the coding is just a Jupyter notebook. It's nothing. You can code in like 3 or 4 hours.
For sure.
So, yeah. So what I do, so how do I balance? So I try to be very strategic about what I do. And typically it's, okay, try to focus on competitions when I can apply new ideas
Hmm.
and do it differently. So, for example, of course in the DD I mentioned, so it was different because we use like a recurrent neural networks for LiDAR, which I think nobody has done. Then from the other one from Carvana, we did something different, which instead of taking just the unit for the whole image, so we
Hmm.
take like a first step, unit on the whole image, and then we did like a refinement, taking like boxes of the perimeter that has found. So it was kind of new. There was
Right.
one other participant that did the same thing.
Hmm.
Um, and then I've seen this approach more polished because our was like 2 steps taken by doing by research at Uber. So we were into something, new things. So I always try to focus on things that, okay, even though if I'm not an expert, can I do it differently enough with small effort in
Right.
terms of coding and time? And then I can like throw the problem to my computer, and then
Hmm.
it's just letting it train for a few days. I check, I stop the experiment, I launch it again, but that's not really a lot of time. So
Yeah.
it's mostly taking care that the computer is alive and training.
But I'd again like to highlight that since you had this rich experience of working as a software engineer over the few years, that's also helpful. So for me, for example, training something might take maybe a few days that you could, I imagine, code in a few hours.
Well, I don't know. I think one of the things is that so initially one change I've done, and this is thanks to fast AI and Jerry Howard, is this idea of interactive programming,
Hmm.
which is historically I was used to code in like a Visual Studio or even like Sublime Text environment, which you don't get immediate feedback of what you're
Right.
doing. So
Hmm.
sometimes you spend a lot of coding, then debugging, etc. So that may be good like for production systems, which you
Hmm.
have to know like software engineering, like proper like maintainable code, etc. But then this blend of good software engineering practices with interactive programming, like when I was a kid, we used to have basic that the first thing you saw at the computer was like a basic interpreter, right? So you
Yeah.
even to load a game, you have to program or type something, right? So that was a good experience. So I think right now it's this interactivity paradigm, which you can immediately like launch the code. If it's wrong, then you just put another cell. Makes
Yeah.
you go much faster. So I think that's a great advantage. But then, of course, knowing programming really helps, and that's something I recognize. Sometimes I take for granted, and sometimes it's not the case. But yeah, but also we have to keep in mind that Python again is may not be an efficient language in terms of the CPUs per thing accomplished, but it's a very expressive and effective language. It may not be efficient, but it's
Yeah.
very effective. And today we are trading efficiency for effectiveness.
Hmm.
And I think it's especially good for beginners.
Yeah.
C++ is more efficient, but would lack as a beginner doing machine learning with C++.
Also curious about your take. I'm not sure if you've checked it out. Swift for TensorFlow. So Fast AI founder Jeremy Howard is really pushing for it. What are your thoughts on that?
I think that's I always so there's people coming to me and say, how do I learn machine learning, etc. And I say, I'm thinking in my head, if you are like 16 years old, like do Swift because it's the new thing that is coming. And I see it this vision of getting the atomic unit.
Yeah,
I don't know if you've gone through the lessons. So
I
getting
have.
the atomic unit be the internal representation that gets compiled instead
Mhm.
of interpreted. And the good things in Python are because they are not really in Python, right? The NumPy, etc. Like TensorFlow, PyTorch, none of that is really Python. So you get the Python API. But that's it, right? So that's going to hinder eventually. And when you program, like the trend today, if you look at the AMD processor, it's really more parallel processing.
Yeah.
And doing parallel processing in Python is a mess. And it's fun that the Python community at large doesn't recognize that as a problem.
Hmm.
If you've, the famous GIL, the global interpreter lock
Yeah.
thing, that's to me, it's crazy that you have to do things like Jeremy has like tried to simplify somehow with the parallel function
Mhm.
a bit, which, I used to do manually. I just use this parallel helper function that, but again, it's been processes. Sometimes when you launch many items, it gets out of OS handles for all the open files that get created. So it's a big mess,
Yeah.
but it works, right? So my vision is I'm really excited. So I'm really excited about the possibilities, but
Mhm.
today I'm not using it because two reasons. It's still way too immature,
Yeah.
and I say I don't have the time. So because I want to do less code and make sure it works. Um, and also, as far as I know, and I may be wrong, at least in release candidates, TensorFlow 2, even in eager execution, in eager execution, is significantly slower than PyTorch.
Yeah.
And for competitions, speed is critical of experiments. So that's one
Mhm.
of the reasons I'm not using TensorFlow 2, even though the eager paradigm, which is of course borrowed from either PyTorch or even Theano's,
Mhm.
Theano, um, is better than the graph approach in my view, or easier in my view.
Got it. So there's a question from Corey Levinson. I think this is specific to your current gold winning solution as well, but maybe you can talk broadly about that right now. Why do you choose fast AI instead of native PyTorch?
I think so. PyTorch, I think I've made the answer already. So PyTorch has this imperative model construction instead
Mhm.
of the graph-defined model. So it's easier and more flexible in my view. Um, and then Fast AI sits on top, so you get lots of goodies from Fast AI. So
Right.
you get like learning rate, Finder, one line of code. Great for my paradigm, right? You
Yeah.
get training loop, again, like feed one cycle, one line of code. Uh, right? So it's difficult to beat that. Of course, you can do everything, manually in Python if you. But then the beauty of Fast AI, which may not be evident when you use it, is that if you invest time
Mhm.
with the callback systems, then you can do. I think everything you can do manually,
Yeah.
you can do with the callback system, even in the current version, which is version 1.0.
Mhm.
Um, so of course you have to invest. Callbacks are easy. I think the most difficult part that I had more trouble is the data bunch, and data blog APIs
Yeah.
because of the cascading way in which they are built. That's where, especially in a solution when you do not use the pre-built what they call the libraries for vision, for text,
Mhm.
tabular, right? When you are outside of those, like
Yeah.
walled gardens that are things are easy, and then you have to build your own item list, and then
Yeah.
gets a bit more, I think it's more difficult than Keras, where you just have a generator that
Mm.
spits out data. Maybe
Yeah.
the generator is more low level, but you grasp it immediately. Whereas in Fast AI, you really have to buy into their architecture, which
Yeah.
you do,
Mhm.
but requires a bit more of a learning curve. So I guess the short answer is you get the best of both worlds.
For the audience, I'd like to mention, and this episode is being recorded on 1st of September. They are actually building the 2.0 version of the library, and it's open to contribution if you'd like to invest time there. So you can maybe jump in right now and also learn the architecture as they build it.
Yeah, it's to me the fast AI. So there's the fast AI latest. I don't know which version it is of the
Mhm.
course. I think it's V3, which is really V1 of the library, right?
Yeah, yeah.
So V3 had like two parts. The initial part, which is, is basically a walkthrough through the library, right?
Mhm.
But then the second part to me was like mind blowing, like really mind blowing. Like
Same for me.
it's very unusual for like software engineering or for a from my perspective for the creator of a library to tell you like how they do it, the workflow, and
Mhm.
this workflow is very different from anything I've seen, right? So and then doing things from scratch the way they did it to me was like completely mind blowing. So if you've done the first, if you have not done the fast AI course, I really recommend it, like the go to course to do right now. It's very accessible, top-down approach. It's kudos to uh, um, Jeremy and Rachel and Sylvia and the Fast AI team for building it. But then when you finish, like the second version that they go into details
Yeah.
on why they did it and how they did it is just amazing. The only the only thing I really had, which is very picky, that
Mhm.
they've largely addressed, and I admit I complained in the forum, and then I didn't do anything
Mhm.
in terms of fixing it, like contributing, because I don't have really time, was
Right.
the naming. So there were some naming inconsistencies initially that they've
Mhm.
like a CNN learner, remember for image,
Yeah.
that they've changed. They have different names, so they change it. So there's and then also in my mind, there's still a fight internally between having all these crazy abbreviations that you
Mhm.
each time you read them you have to process. For at least for me, that I'm not a native English speaker, so I have to see like why they use I don't know um, um, a smaller version in this
Right.
place and the longer version in this other. So there's consistency in naming. But again, this is you cannot really complain. You're getting this for free, and
In
really,
my
right? I mean, it's done. Jeremy is funding this, so it's to me it's like really mind blowing. There's no like a company like MXNet. They have Amazon, right?
Yep.
TensorFlow. They have Google. PyTorch. They have Facebook. So there's interest in all those three. So the interest here is pure, and the interest, and they've built the library not only from solid engineering principles because of the high level goals that they have in terms of making this accessible.
Yep.
So to me, it's just mind blowing.
I also followed on Twitter that Jeremy will never accept any form of donations for the fast AI efforts also. So I don't know why or how they do it, but it's totally amazing.
Yeah. That's crazy. Yeah.
Another thing I personally want to mention is once you get the hang of the naming convention, which may take a while, then it's definitely rewarding because then you can easily wrap your head around the architecture that we were just talking about and the complete practices. So if you like do invest some time there, it's definitely helpful in my experience.
Yeah. I really wish I had the time to contribute to version 2. Really, I think I need to, I don't know, clone myself. Dot clone. Uh,
Interesting. Okay, so the next question, I think you answered this in some extent. Maybe you could quote some examples, but Alison Davy asks, how has what you have learned taking part in Kaggle competitions impacted your professional life?
Yeah, so I think so I'm going to already say it. So before I started from a curiosity standpoint, so now I see, okay, why don't we do this, and we are actually doing it. Then I
Mhm.
think the difference between and this is pretty obvious, right? The difference between there's few differences between a Kaggle competition and production. The first is in a company is the data set, right? That more often than not you do not have the data set.
Right.
Luckily, we already had the culture internally of being extremely data driven, so we
Mhm.
already have and kept the data that we are using for training. That's one thing. But then the other thing, which is, this the whole life cycle of
Mhm.
deep learning model is not really, as far as I know, we don't really have like super best practices for it. Like, do you retrain every day? How does online learning work in practice? Um, what is if you're deploying, like if you do like automatic deploying, like what you
Yeah.
do in software, that you do continuous delivery,
Mhm.
does continuous delivery work from the learning models? Um, do they require validation? What sort of, so there's all these things that explode that you can really understand that in the software 2.0 world we don't yet have the best like software engineering practices that we have in the software 1.0 world that we've taken maybe 20, 30 years to develop. So we are in, you know, data point almost zero. So that means there's lots of
Yeah.
opportunities to do products and ideas in the software 2.0 world.
So the next question is again from Andre Lukianenko. How do you choose in which competition to take part in for Kaggle?
So I think it has to add something for me in terms of learning new things. Um, so I really like challenges. So for example, in this molecular prediction one,
Yeah.
I think so. My teammate Pavel reached out and say, "Hey, have you looked at this competition? I've looked at that, and it was. I think oh, this is really difficult, right? Because they have different molecules. It's a graph. They want you to predict many different things in the same molecule, but there's not always the same things. So I had really no background in quantum mechanics or anything like that. So I
Mhm.
just know like a high school level chemistry, which is
Yeah.
just like drawing the molecule almost, right? And knowing that different type of atom exist. That's it. Um, so 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 again, so this one it was like a challenge,
Mhm.
and yeah, it was a nice challenge. And again, and also the fact that okay, if I'm approaching this I want to do it in a lazy way, which is let the machine do the feature engineering.
Right.
So it's the same. Like I joined and have really low, um, accuracy and score in this. There's now an IEEE fraud competition
Mhm.
that is mostly tabular data.
Right.
Right, it's really tabular data. They are anonymized with some meta feature, etc. And the winning solutions right now in the leaderboard, they have like almost, as far as I know, all of them because of the forum comments, etc. use boosting
Mm.
algorithms.
Yeah.
So and then like manual feature engineering,
Mhm.
picking this part or the other. So right now I'm saying, okay, I'm going to join this competition, but I want to do it with deep learning, which so far is not competitive. I haven't seen really any competitive good spot in the leaderboard with deep learning. So I'm trying, and of course, this is not using. I've tried already using like the tabular, solution
Yeah.
from fast AI. It doesn't cut it, right? It doesn't cut it at all
Mm.
because there's things that, like for example, there are things that a deep learning model cannot really see, like the
Sure.
frequency of an
Mhm.
item, right? Or when you have like in tabular data, new items that do not show up at all in the training set, and they
Mhm.
are in the test set. So there's test versus train disalignment. So then I said, okay, could I do what there was this I think great solution from a previous one from the Microsoft fraud, um, um, sorry, not fraud, the malware
Yeah.
competition with I think his name is CPMP,
CPMP.
CPMP solution that they manually try to align the two distributions
Mhm.
manually.
Mhm.
So I think so. I'm joining this one. Maybe I don't succeed. I don't know. We'll see. With the idea of trying to align two distributions with deep learning, in
Yeah.
which I wouldn't have to do anything. So
Got it.
it's still very. So again, so it has to be challenging in a way that I give the best representation I can find, so the computer does my job.
Got it. That sort of gives us an insight that you always look for a challenge, but then you're also take a lazy approach where you like to just do the human parts and leave the computational parts for the computer.
Yeah, well, I think that's the promise of deep learning, right? And so far, it's shown that again, if you have enough data,
Yeah.
the representations that it finds are sometimes the issues that we do not understand. Sometimes those representations, that's an issue because
Hmm.
we haven't built them.
Yeah.
It's not really a surprise, right? We don't understand how the brain works. So it shouldn't surprise us that something that we've been inspired by,
Right.
right? Also, we cannot really fully understand, although it's easier than in the brain. But that's the idea. So if you can use deep learning, have enough data, you know, I think it's kind of good to be lazy in a way.
That's very true. Which brings me to the next question, which is by Michael ML. Sorry if I got that wrong. It's Michel. Can you describe your high level approach when competing in a Kaggle competition, and what is your machine learning workflow?
So okay, so I think the high level approach, to be honest, I don't. So to be the right answer, which is not my answer, the right answer is there is a great post by Andrew Karpati about how to tackle machine deep learning problems, which is very systematic. Like first, you build a model and you try to overfit it with just one or very few samples to
Mhm.
make sure that nothing is really broken. So that in the software 1.0 equivalent, this will be what used to be called like a smoke test, right? That it doesn't explode,
Right.
right? So that's so the right answer is not mine. Is Andrew Karpati answer. What I do, it's in Kaggle in competitions is a different thing than in a commercial project. So
Mhm.
first is the first thing is even before downloading the data, I look the kernels or notebooks that do the exploratory data analysis because there's great people that are really good
Yeah.
at showing the data. So that's even before joining. Okay, what if I join this? What I'm going to deal with? So that's
Mhm.
the first. If I'm then I also look at the metric. Okay, is this metric make sense?
Yeah.
Um, is it differentiable? Is it not? Can I be like enough good enough proxy?
Mhm.
And then in my mind, I think, okay, how would can I approach it?
Mhm.
Can I come up with and this is even before joining.
Right.
So just thinking about it. So this, might take just 1 hour, really.
Mhm.
Looking at all these things and making, in your head the picture of how it looked like. So if it looked like I join, download the data, and then I do the things that I have suspicion that may be useful
Mhm.
in terms of data representation or analysis, just in an interactive way in notebooks. It's way worse than what people publish. So it's very ugly.
Right.
So, maybe I just get numbers, I don't get fancy pictures. Sometimes sometimes you have to do them. Um, so that's the initial thing. Then I build like a toy model initially. One thing that I used to do, and in retrospect, is thinking really hard about the data representation.
Okay.
I think that the input representation is key. So even in images that you may take for granted that you're going to throw in pixels,
Right.
right? RGB pixels. Sometimes, you know, depending on the scenario, there may be other ways.
Mhm.
Example, Carvana competition, right? So you get JPEG pictures, right? Internally, I think many people know that JPEGs are compressed, right? At two levels. So one is at the kind of entropy level, which is far outside our domain, but the other is in the color space level.
Right.
So in images, machine learning models are usually trained with RGB, but there's a better representation because of how we perceive things which are being exploited by the compression algorithms, which is luminance and chrominance, right? So in the Carvana competition, for example, I did this UNet in which you would feed just one channel of luminance on the top, right? And
Yeah.
then once you do the downsampling, you feed the UMV
Mhm.
channels. You save memory and you get more expressiveness. And
Right.
also, for a competition, which is back then, I used to have a small, less powerful CPU.
Mhm.
Um, I created like a small, different fork of the Turbo JPEG library, which incidentally fast.ai uses,
Mhm.
that you kind of get the components um, automatically. So it's even faster JPEG decompression because it doesn't have to do the color space reconstruction. So it's
Right.
faster. So then, okay, can I use this JPEG thing more natively because the images are given to us in JPEG, right?
Mhm.
And if you think about it, when you decompress, you are upsampling the image.
Yeah.
So, these things happen even before I start,
Mhm.
right? Then, okay, then I have to look if there's like an open source JPEG implementation that I can easily, like do surgery in, which in this case was
To
easy,
take the
right?
lazy approach.
Yeah, exactly, right? Because I'm not building
Yeah.
a freaking JPEG library. So in that essence, that's input representation. So it's getting a sense of the data loss function, input representation, build a simple model, and then you can almost see immediately, right? If your
Mhm.
model, the first model gets decent approaches, that's a good start, right?
Mhm.
So that's pretty good. Um, and then uh, and then is training is like the boring part, because and again, sometimes I agree with Jeremy that today you can do with one GPU what before require like a cluster,
Mhm.
but competitions are competitions, right? So for like this happened to us in the molecular one. We lost in
Right.
the last few hours. For 1 decimal point,
Mhm.
right? Maybe because there's thousands of teams participating, and more likely than not, the top teams are using approaches that may be similar to yours. So
Yeah.
sometimes, ensembles wins or more computing power wins.
Mhm.
So then I ended up in my house with 5 GPUs. So that's so I
Okay.
started. So I remember when I started, I used to have like retrofit my gaming machine. I like gaming, PC
Yeah.
gaming. So I retrofit So then what happened immediately is I couldn't game anymore because the freaking computer was like training constantly, right? And I couldn't stop it, and I shouldn't stop it. Although
Mhm.
you can do checkpoints, but especially back
Yeah.
then, it wasn't so sure that you will get the checkpoint with all the optimizer data that you can resume right. So model training, like then you see a part, and then it's just iterating that cycle. And at the very end, that's my view. I'm not good at ensembles. I'm not
Mhm.
good. Um, but at the very end, we typically, and this is also, I think, when I do with Pavel, when I've done alone, I haven't done ensemble because I don't have enough machines, but he
Right.
also has a few machines, so he's pretty good doing the ensembles, which
Mhm.
is typically I don't touch.
Okay. What would be, this is slightly off topic, your favorite game maybe today and back from the days of Try Media?
My favorite game. Okay, so that's easy question. So back from days of Trade Media, this was very funny because Trade Media, we did PC games distribution. So it
Mhm.
was funny because I was working with games like testing and every day. I didn't play much
Okay.
until Halo came out.
Okay.
So my favorite game, I would say, I don't know if all time, but one of my favorite games ever is Halo,
Mhm.
and I'm very proud. I'm equally proud. This is funny. Equally proud of my machine learning experience
Right.
than like having finished Halo 1, 2, and 3 in legendary mode, which to me is like a super achievement, like playing solo. So that's and I'm not a good player, so I'm almost embarrassed to say how many hours I've put into those games.
I never got
So
past normal mode, so
yeah,
huge respect to
so,
you.
yeah. So legendary, especially in Halo 2, I think it was crazy. So and today, to in the very recent games, and this is a
Mhm.
very funny story. So I think MGS Metal Gear Solid 5.
Right.
It was because, and this is, you're going to laugh about this. When you
Okay.
start the game, it asks you your name, did you build your thing, right? And it
Yeah,
asks
yeah,
you
yeah.
for the day in which you were born. And I type it in, and I forgot about it, right?
Mhm.
And then like spent like many months playing the game, right?
Okay.
Maybe I put 100 hours in the
Okay.
game. And the day of my birthday, which I have forgot that I put my birthday in the game,
Right.
I was playing, and then they call me, in this game, your base gets invaded. So sometimes your home base
Mhm. Yeah,
gets
yeah.
invaded by a team, like online team, and you
Mhm.
have to go back. This happens in the game a few times. So
Okay.
you have to go back and defend it. Like you're in a mission. Hey,
Mhm.
they call you, hey, boss, come up quick. The base, there's a problem in the base. You
Yeah.
have to come up quick, come back and defend it. So I freaking out, like they're going to steal all
Mhm.
my things in the base. I go back to the base, right? And then there's all the base members, they
Yeah.
sing me happy birthday on my
Okay.
freaking birthday, which I forgot. So I was like completely blown out by this, like I almost crying in the computer screen. So that's very recent. And right now, because I have like a super like a incredible gaming gig
Mhm.
because of the learnings I have in
Yeah.
my main machine is a Threadripper with 32 threads and
Okay.
three 280 Ti RTX cards,
Interesting. Yeah.
okay, and
Yeah.
two in SLI.
Mhm.
So it's 4K with ray tracing, with all the
140
bells and
FPS.
whistles. Yeah, so it's and I play in a big screen with a projector, 4K projector.
I'm really
So
jealous of you, honestly.
this is right now because the last GPU I bought because of this competition,
Yeah.
because of the last one, because also there's a different reason, which is because my wife, she's a doctor plus software engineer and he's got recently a PhD on AI. So
Mhm.
we are like competing for GPU resources at home.
Okay.
So, so then I bought the third GPU for her, for as I was training with the two of them, because I have like the computer completely
Yeah.
for me. So right now, and then with this third GPU, you get like two games for
Mhm.
free.
Mhm.
One was Wolf Tame, Young Blood,
Yeah.
and the other was Control, which
Yeah.
is
I
from I
played
think
Control.
Remedy.
Mhm.
Control. So Control. So I'm right now playing Control, which is of course the graphics are I think the best I've
The
seen.
RTX is pretty amazing on that game.
Yeah, yeah, that's I think the game because I bought Metro Exodus because of ray tracing,
Yeah.
but honestly, it's a hard sell, right?
Yeah. Yeah.
So so far, but in this game, it really makes a difference. So I'm playing Control right now. So
Okay.
that's it's I think I have like a window of free GPUs until I like join the next competition.
Okay. That's really interesting. So, coming back to the world of machine learning, congratulations to you on your amazing finish on the molecular competition. Your team placed second on the leaderboard, and also congratulations on becoming a competitions master.
Thank you.
I'd really love to get to know more about your solution, but before we get to that, could you help us set the stage and tell us what was the quote unquote predicting molecular property competition challenge about?
So this is like a great competition because not only is a challenging problem which I'm attracted to, but
Mhm.
also because the usefulness for the scientific world I think is pretty high, as the organizers, explain in the description. So it's basically what the competition is about. It's in chemistry. When I studied chemistry, it was very experimental, right? So you have a molecule and you have a very similar molecule, and let's
Right.
say one of them explodes, if you add water, and the other does not, and they look the same, right? This
Mhm.
doesn't really happen in physics. Like if you see things similar, you can also anticipate the behavior, right?
Right.
In
Mhm.
math, somehow if you see a formula, there's exceptions, but you can anticipate and predict. But in
Mhm.
chemistry, when I studied when I was a kid, it was really unpredictable. You have to do experiments.
Right.
So initially we did experiments. Now because molecules are very small, right?
Mhm.
Atoms, right? So it's Armstrong's distance. At that level, there is like quantum interactions that
Okay.
happen, and
Mhm.
that's really why it's difficult to predict because we really didn't understand the quantum world.
Right.
Maybe 20 years ago, or we didn't have the capabilities of simulating the quantum world. So today we have better understanding of the quantum mechanics that really, you know, drive those, properties
Mhm.
that molecules exhibit, and we can simulate them in a big computer. Okay.
Okay.
Those simulations, however, take time in a
Yeah.
powerful computer
For
because you
sure.
have to simulate crazy equations that are very difficult, which I have no idea and no really interest of
Okay.
knowing a lot, right? They're
Right.
super complex, require you to do a PhD in quantum mechanics, which I don't have time. So,
Yeah.
um, so a group of universities, mostly in the UK, I think, they thought about this and say, okay, we are going to simulate, or we have simulations of around, let's say, 140,000 molecules
Mhm.
that we know we've simulated their properties in big computers. Each simulation for each molecule takes 1 day or 1 week in a
Wow.
computer.
Okay.
So, okay, so, and there are small molecules, so 29 atoms at max. So, and you can calculate with the types of atoms that they use in 29 that
Mm-hmm.
there's billions of potential molecules. And I'm
Right.
sure there's treasures
Hmm.
in those billions. So maybe there's a molecule that could be a good drug for a disease. Maybe there's a molecule that could be used for solar panels. Maybe
Right.
there's a molecule that can be used to extract oil from the sea when
Hmm.
there's an accident. So there's treasures, right? However, we don't have the resources because it takes days or weeks to simulate the behavior. So they say, okay, could we do a shortcut?
Okay.
Could the machine learning community build a model that doesn't run the expensive
Hmm.
simulation and somehow shortcuts and does it really quickly? So that's their motivation,
Okay.
speed. Okay, so that's the context. So the first thing I did when I joined is I remember I emailed the organizer and said, okay, this is great, it's a competition, but it's a challenging competition. I feared that what may happen, which didn't happen, which may happen is that some team wins because somebody has to win,
Yeah.
but their solution may not be usable
Hmm.
because it's not accurate enough, right? It's
Right.
fast, but it's not accurate. Then it
Mm-hmm.
will be, waste of, it's not a waste of time. Maybe they will say, okay, machine learning is still not mature for
Yeah.
this problem. So that's science, right? So
Mm-hmm.
you learn from the impossibilities sometimes.
Okay.
So I asked them, okay, what is your threshold of success?
Mm-hmm.
And the organizer responded, which was great. And he said, okay, if people, so this is basically, this competition is measured by accuracy,
Mm-hmm.
simplifying, and it's measured on a logarithmic scale, which
Okay.
means that is the for those that don't know, is the opposite of exponential. So from exponential, you increase a bit and goes really fast. So
Yeah.
here, going like 1 point down is exponentially more difficult as you go down in
Okay.
this score. So he said, okay, if people finish above -2, it's not so good.
Mm-hmm.
Um, People finish between -2 and -3, it will be good. But if people finish below -3, I will be, his word, extremely excited.
Okay.
Okay. So then I already have like a goal. Okay. We have
Yeah.
to get to -3. So it was really difficult.
I
So
think the
then,
best solution is minus 3.2 something. I'm not.
yeah. So there's
Okay.
a, actually, so I think we finished with uh, 0.01 or
Mm-hmm.
zero. So it's, yeah, super tiny difference, but again, it's exponential.
Mm-hmm.
And then our single model, one model only,
Yeah.
so far published, I think our single model is the best. They use different ensembles,
Mm-hmm.
very smart. So they got with ensembles more score. We use, I think, it's more similar models because we retrain them. So we're
Right.
not as diverse. So we lack computational resources. But our
Mm-hmm.
single model was -3.16, which
Okay.
was more precise than their number one, which -3.09, if I
Hmm.
recall correctly. But again, so at that level, every solution is I think super good.
Yeah.
Um, so that's the framework of this competition. So what they make you is they give you a molecule
Mm-hmm.
that can have 3, 5, up to 29 atoms, and they
Sure.
say you, okay, what's the magnetic interaction? To be honest, I really don't know exactly what that is. Okay,
Okay.
it's called a J coupling. So it's a
Mm-hmm.
number. Okay, so it's a number. That's good to know. It's just a single number and a scalar number
Yeah.
between one atom and the other. It's like the magnetic force. I have no idea.
Mm-hmm.
Okay, of really what it is.
Sure.
So that's the idea. So that is, but then it's really for a molecule you may have up to hundreds. Well, I think it was 180 something. In the data set we were given potential coupling. So because in the water molecule, it's between H and the other H, or H and the oxygen,
Mm-hmm.
right? So different combinations, but there are some combinations that are not really explored. Maybe they're not useful.
Okay.
So it's a difficult problem, right? It's a molecule that has, they give you the molecule with the atoms position in space,
Mm-hmm.
right? You can derive the bonds of the
Right.
atoms,
Mm-hmm.
and you can build a graph. Um, and then they give you the kind of pairwise interactions that you have to predict. So that's
Right.
the context. So it's a very challenging problem. And
Got
if
it.
you look at the literature, what you're going to find is that the state of the art before the competition, because the top solutions, the three top solutions, beat the state of the art networks,
Mm-hmm.
are the state of the art previous to this competition was um, graph-based models that
Okay.
take the input somehow in terms of a graph.
Hmm.
And
Got it.
so again, so I look, if I going to join this, I need to do something different. So I'm not going to look at graphs because again, so let's see if we can get something that is different. So then, so it's same my workflow, right? So what
Right.
can I think about? In this case, so also the loss function is very easy, right? Because the metric is differentiable.
Mm-hmm.
So that was easy in theory, but so it was easy. Then, so the input representation is the issue, right? In this
Yep.
case, so and there's, and you look at the forum is crazy, right? They talk about diedrical angles
Yep.
and quantum stuff, right? About the molecules and the bonds, the types of bonds. So you have to be an expert. I said, I don't want to become an expert. I cannot become an expert in 2 months. So then I said, okay, what is the minimum representation that
Mm-hmm.
contains all of the information? So you may
Right.
be tempted to think it's a graph
Mm-hmm.
because that's how we've studied chemistry,
Right.
right? But it's not really a graph because
Interesting.
the graph can be derived there with the 3D points. So
Right.
if you know the atoms and their positions,
Mm-hmm.
there are no possible different graphs. There's just one
Right.
graph, right?
Right.
That
Makes
that
sense.
because of the laws of nature.
Mm-hmm.
Um, so with that thinking, I always try to feed the network the most entropy, right?
Okay.
Less redundancy. And in
Got
this
it.
case, the graph in my view is a redundancy.
Mm-hmm.
Okay,
Got it.
so that's the first thing way of thinking. Okay, so then it really becomes easier when you start in this path because you say,
Mm-hmm.
okay, I'm going to feed the network with and this is going to sound funny now, with an ordered set of points. Does it look
Okay.
familiar like a point cloud? It does,
Yep.
right?
Yes. Yes, it
Really a
does.
point cloud. An atom
Yeah.
is a point cloud. Okay, so now that we have a point cloud, now the issue is that, and that's so so let's say that you only have one source atom in a molecule, and you have to predict just from one source atom the interaction between different atoms.
Mm-hmm.
Doesn't it look like a segmentation regression problem? It kind of does, right?
Right.
Because you have to predict a value for each point,
Mm.
right? A
Makes sense.
value. So and a segmentation is really a value, but at the end you do like a softmax, right?
Yep.
Or yeah, but it's really a value down in the network mind, if you will, is a value, right?
Yep.
So why not predict this value as a relation directly? So that was the thinking. It's very simple, right?
Mm-hmm.
So you have like a 3D point, um, just a cloud of 3D points. You have a reference atom, and you have to predict. So then we use PointNet, which
Okay.
I already have experience with. So
Mm-hmm.
with PointNet, we managed to get it up to minus 2.2 or 2.3 score, right? But
Right.
then every experiment ended the same way. We were not able, and then it was very unstable. And I was thinking why that happened in terms of the network,
Mm-hmm.
and it's because, well, you have to really dig deep in the pointing architecture because it's really trying to find functions in a super high dimensional space that
Right.
gets squeezed at the very end.
Okay.
So that wasn't going to cut it in this competition.
Mm-hmm.
So then I thought, okay, what other, and this is a difficult question. So what other architectures take unordered sets of, let's say, items, unordered sets, and that's the
Okay.
key, like an unordered set,
Mm.
right? And not many, right? So in an image, kind of the point is where it is. It defines the image, right?
Right.
You cannot shuffle the points around.
Mm-hmm.
By definition, the recurrent neural networks are order dependent because
Sure.
that's really a feature of them, right? Um, Fully convolutional layers, because of the weights, how they are structured, they know which neuron they are accounting for the weights, and
Right.
that's position dependent.
Mm-hmm.
Also, not the kind of the bare bone functional block, like the fully connected layers. But then um, I look at I actually heard about a podcast with one engineer from Google Brain and DeepMind, Oriol Viñals. There's a good podcast that Lex Friedman does on AI.
Yep.
And he, like on the passing says that transformers, the inner blocks of transformers are position independent, and they had to really come up with an idea of add positional information. And then I said, okay, this is it, right? That's it. So I just removed the positional information.
Got it.
This is more complicated than that, right? But that's the kind of the idea. The idea is you can use actually the transformer blocks encoders without encoding positions or where you put, if the oxygen you put it in the first item or in
Yeah.
the second, it doesn't matter because the positions are in the actual vector, right? And then that was it. That was the breakthrough idea. Then then what happened is that the transformers are huge to train. So if you've seen the famous or infamous like OpenAI GPT-2 drama, right,
Yeah. Yeah.
about releasing the models, etc., they've used, I don't know, hundreds and hundreds of GPUs to train those models because they are huge. Our biggest model was 1 million, well, sorry, 100 million parameters.
Okay.
It's the biggest model I've ever trained.
Mm-hmm.
So, unluckily for us, um, because I'm also very impatient, I, in this case, my teammate did was more patient than I was, so he left their models training for longer.
Mm-hmm.
But in my case, my free GPU at home, like I only put the max time I did train was like 3 days.
Okay.
And if we have let these models for running for 1 week, they have enough capacity
Mm.
to eat, quantum mechanics and more.
I think, unfortunately, Distilbert came out just recently, but giving that a shot might have been interesting.
What is it?
Distilbert is a transformer from Hugging Face.
Oh yeah, I saw it. That
Yeah.
they're like yeah, but this came like
Just
three
at the
days
end.
before the competition. So
Yeah.
strategically, and also we have other ideas. The idea, the input representation is we take a molecule like a source atom, and then we build like a point cloud of that. For a different source atom, we build a different point cloud, which is just moving the source atom to the center of coordinate space. That's
Right.
it. Um, but then we also have one idea that we internally call this we call the atom transformer, because we create like a one different molecule per atom.
Mm-hmm.
They're like, we call them siblings, but it's just changing the reference points.
Sure.
But then we also have this 90% implemented, which really means 50% in the real world. But in my mind is 90% implemented, the molecule transformer.
Okay.
I think team number 1 and team number 3 did, which is to predict like all the couples in one shot.
Mm-hmm.
But because we were training and it was working so great, we decided to invest resources in just training the models because we didn't have enough GPUs. So if we had enough GPUs,
Mm-hmm.
we would have trained for longer, and also I would have had resources to test the molecule transformer if it was
Right.
better or not than the atom transformer. But that's the game.
Got it. Uh, for reference again for the audience, you're talking about all of these molecular properties and quantum mechanics, but did you or your teammate have any background or domain knowledge about this before joining?
Nothing. That's one reason why we actually consciously decided not to pursue this approach.
Mm-hmm.
So So I say I work at CERN, but my work at CERN was just an engineer doing testing that the electronics were working okay, etc. So
Yep.
it didn't really involve quantum mechanics, etc.
Hmm.
And Pavel, my teammate, he's a software engineer working in deep learning, so he does have pretty solid deep learning background because his actual job is
Yep.
deep learning engineering, but he also doesn't have any background on this.
And for context, many of the top leaderboard teams were actually had a lot of domain knowledge, and these people were stacked up against your team.
Yeah, yeah, that's yeah, but this is what always happens in deep learning.
Yeah.
That you can see like an outsider
Mhm.
come in. So this very similar also happened. So again, there was other competition that we have not discussed that I did with Pavel, which is similar in. There are always actually two, but the most notable one was the I talk about Didi, but
Yep.
we ended number one in Alibaba
Alibaba competition.
lidar in China, which that was crazy. That was crazy, and some of the teams actually, even the it is funny because we were like submitting, and then I look at the Alibaba researchers that organized the competition, etc., and they dealt with point clouds in a very convoluted way
Mhm.
for lidar, and then we won this competition because again the input representation. We changed completely the input representation of lidar. We made it into a dense matrix, better than projections, which were not projections. So it's kind of weird. Very like a, it's kind of the JPEG thing, like the
Yeah.
native output of the sensor,
Mhm.
but condensing a dense matrix that has some holes that you can account for in the logs function. And then we ended up number one. Again, people that were experts in point clouds and they had these sophisticated point clouds architectures with voxels and things. So sometimes, yeah, it's so my view, in a I think in software engineering and in many disciplines, when you start you maybe you doesn't even work, then it works that is super complex, and what I strive for always is for the solution to be simple.
Mm.
So that's difficult. It's, sometimes you get it, sometimes you don't, but I think that you should strive for simplicity in the solution,
Definitely.
and it's not easy. So it's not that it's easy. It's simple.
Yeah. Yep.
Sometimes simple is more difficult,
For sure.
but I think that's what you should strive for.
That's why I found it funny, because I could see myself actually went to the competition while researching upon your profile, but I could see myself going up on that path of learning about voxels and their representation instead of striving for something totally simple like you did.
Yeah, yeah, yeah. And then there was the other competition about feature engineering, etc., which was the one competition that I joined because I thought it was impossible.
Hmm.
This is so funny. So there was the IEEE camera detection. I don't know if you know about this one.
Yep.
So
I
this
do.
was one. This was so fun because the idea here in this competition was they give you a picture. This is like a CCI, right? The TV series, like
CCTV.
a police. So they give you an image, and you have to predict which camera
Hmm.
made the picture
Yep.
out of the pixels. You don't have metadata, nothing. No, you have pixels only, right? And not only that, you can have pixels that have been compressed in JPEG and blurred. Oh
Hmm.
my God. So if you think about it, I thought, this is not possible, right? To do this.
Yep.
So then, so then I remember, so I participated in this one. So, I just build like a blindly, right? If you, let's say that you are like an extraterrestrial, right? And you come to Earth and they give you pictures of dogs and cats, they look crazy to you, right? You don't have even, right? So, but you
Yep.
put them in a box, right? With labels, and out comes dog and cat, right? So I
Yeah.
was thinking, if I was a neural network, right? That was my kind of crazy thinking. Could I detect the camera out of the pixels?
Interesting.
And so the question is, and could I detect a dog out of a cat? So from the perspective of the neural network, it's a similar problem, right? So
Yep.
if you are looking at each neuron, right, what it does, so it doesn't have high level motion as far as we have. So then I did what everybody would do, which is put like a classification neural network and feed crazy data in, right?
Hmm.
With the expectation that it will find something,
Yeah.
right? Without knowing what to find.
Yeah.
And then to my surprise, well, I there was a bit in Kaggle. There's this um, tension about releasing kernels that are public
Mm.
with good score. So it kind of happened to me in a way that so I did it at home and I got pretty bad results. So there were like 10 classes and I
Right.
only got like 50%, which is more than chance,
Hmm.
but there were so good solutions were like 92, 93, 94.
So way
So they
off.
were doing something, yeah, way off the totally they were. But in a way I wasn't really surprised because initially I thought it was an impossible problem. So I
Yeah.
said, you know what, I'm going to open source in the competition, not in our kernel, but in GitHub, the solution, and with the expectation of, because it's a pretty bad solution, I mean 50%, with the
Yeah.
expectation that somebody will find a bug or help me or help with the solution.
Mhm.
Of course, it didn't happen, right? Nobody,
Yeah.
nobody was wanting to spend time looking at faulty code, right? And then I was walking and I realized that I made a bug in the code. And
Hmm.
the worst thing coming from software 1.0 to software 2.0 is that the bugs are silent,
Yeah.
right?
Yep.
And the greedy gradient descent algorithm will do anything in its power to find the best solution, even if you try to sabotage him
Yep.
through a bug, right? So in some ways, is your ally. In this case, when you have bugs, is your enemy because it tries to hide the bugs.
That's a
That's
great
that's all.
analogy.
So so this is what happened here. So I found the bug was a simple minus sign, in the loss function that was twisted, right? But it still managed to learn in spite of having a bad sign.
Yeah.
And then it got like, I fixed it and it was like 92. So suddenly it was one of the top solutions in this competition.
And it
And
was
then
open source.
and it was open source. So what
Okay.
happened is that the top teams, um, they created like crazy ensembles
Hmm.
with my code, and I remember I had to in the last day I added like a clause. It couldn't be in retrospect, so it was moving forward that I said that you couldn't use the code if you were doing ensembles because that was my like a license to use the code. But of course, before I had published with this clause, people could just go back and take the older version, which they did, of course.
Interesting.
So that was, but this is one example because some of the teams that performed worse were experts in optics. So they
Mm.
were looking for features like the chromatic aberration,
Yeah.
the spectral analysis, the encoding of the cameras don't have RGB, so they
Hmm.
have I think it's called Bayer, I think, pattern to
Okay.
reconstruct the RGB. So they were looking at artifacts of RGB reconstruction. So you have to
All
be
crazy
really
domain stuff.
yeah, you have to be really an expert in
Mm.
this domain. And the top solutions again, they didn't. In this case, they were just deep learning. So I think we were in the top, I think top five, one of the only team that didn't use any domain knowledge. But I think, which in this case was an exception, I think this will become the norm more than the exception.
Sure. Uh, so you just talked about multiple GPUs as well. I'm curious, how did you effectively use these? Maybe broadly speaking, as well for other competitions, and how were these helpful? And there's a question by Arnab: how did you track your experiments?
Yeah. So now it's way easier than it was before. In fast AI, you just do two parallel
Yep.
and that's it. Now I have two different computers. So far, I have not tried to do distributed multi-machine
Okay.
training. So
But multi GPU.
multi GPU, yes. So in one computer I have three. I've used three, and in
Okay.
the other I have two, and I've used two. And right now, in Keras there's also multi GPU, um, which is easy. Um, and then in fast AI there's two parallel. It has some issues, so like kind of bugs in the library that if you it may not be an issue with the library because if you're running like an interactive programming code, you may execute like two parallel twice, and
Yeah.
then it adds two callbacks, and then it's convoluted because it fails on validation. But if you know what you're doing, you will be okay, and it's super easy to do. And they were actually linear improvement in efficiency. So, like if you have two GPUs,
Yeah.
you double. I always try to squeeze the batch size,
Okay.
always. So
Mhm.
if my GPUs have like 11 gigs each, I try to put maybe 10.5 on each
Got it.
to have like a, yeah, to max the GPUs. And then you have to trade off between memory usage and compute. So
Mhm.
far, I always, so far with the 2080 Ti, memory is the bottleneck, not computing, because I always max out memory, and
Mhm.
also the um, the computing pipeline is full. Um, I don't know if that's the case with. I think the most powerful you can buy today is a Quadro with, I think, either 32 or even more gigs of RAM.
But it's
The next
crazy,
one that
crazy
is
expensive.
crazy expensive, right? The Quadro 6000. The next one, which is affordable, what affordable,
Yeah.
is the Titan RTX, which has 24
Mhm.
gigs, but then it has only slightly more computing power. And then
Yeah.
in this case, I'm doubtful that even if can feed more batches,
Mhm.
that you have enough tensor units or whatever it's called, computing power, to do all of them in parallel. And the
Got it.
benchmark that I've seen from, I think it's called Lambda
Lambda
Labs.
Labs. Yeah.
Yeah, the benchmark I've seen from Lambda Labs is that it is not equal to 2x
2080
220
Ti.
Ti's. Yeah. Now
Got it.
the issue with having like three GPUs in my machine is
Yeah.
that it's a big mess in the machine, right?
All
Because
sorts of issues happen, heating issues, and even like PCI lane management things people overlook.
exactly. So PCIe. So I actually bought the Threadripper because
Hmm.
you have lots of PCIe lanes.
Yep.
But one issue that I didn't foresee was that if you mount like two of the shelf 20 Ti's,
Yeah.
they measure like 2.5 PCI slots.
Yep.
It means that you may get the place where you would fit the third GPU obstructed. So I had to do this for this competition. I also had to do the do-it-yourself electronics that I had to find in China,
Okay.
a flexible PCI extender that I
Got
could
it.
squeeze in like crazy. And then also in the competition, I was getting these errors, like I don't know if you've experienced them. Not many people, based on my search and
I
experience
just
them,
have
is
a single GPU, so probably not.
so the error is like a kernel error, like the GPU has fallen out of the bus, like this cryptic
Okay.
error, right? And if you
Interesting.
look on the internet in this error, you will only find people that have been doing mining, like Bitcoin mining. They have 8 GPUs,
Okay.
right? And it's very obscure conversation about it could be PCI electromagnetic interference because it's a long cable, could be power issues. So but there's no like solution really. So I had to do like I shielded. I was looking. I have to make a picture. Um, I shielded with aluminum film the PCI extender,
Wow. Okay.
and grounded it in
Yeah.
in the
Yeah. That's what I was
case.
getting to.
Yeah, so that was so. I also for this competition, I also had to do
Interesting.
like Howard trying to fix, and I fixed it eventually. So I
Okay.
managed to run the three GPUs, but I need to like clean up the mess. So my computer is like a huge mess. But yeah, but so it works. So the good news is super easy in a computer to have two. Now the only caveat I make, if you plan to have two GPUs, make sure that you address the thermals on the second GPU, because it's likely going to get, depending on your cooling system,
Yep.
it's going to get the hot air from the first one. So make sure that this is addressed. So you have a good case. I don't know. So don't put the two GPUs close to each other
Sure.
if one of them have the fans going in these directions, because this one either may die because of
Yep.
thermals,
Mm.
or it may throttle down and you will get
Sure.
much. worse performance. That's the caveat.
I'd like to drop a quick plug. So I've had an interview with Tim Detmers, who has this amazing write-up about all GPUs. So please do check that interview out in case you want to find out more about all these GPUs. We've also talked about thermals there, so that might be an interesting conversation.
Okay, yeah, I will do.
There's this next question by Michael ML. What computing resources would you recommend to train gold medal models in a reasonable amount of time? And what is the minimal amount of computing resources to be able to iterate and learn fast for a given problem, in your opinion?
Well, I address the second question first. So to learn is really, you can learn with cloud resources.
Sure.
So you can learn with Google Colab. So that's not an issue to
They do
learn.
give $300 in advance, so that's
Yeah,
how it is.
yeah. Well, that's Google, that GCE, right? The Google Computing Engine. So they
Yeah.
give you $300, but the Google Colab is free
Okay.
for
Yeah.
X
Collab.
hours.
Sure.
Yeah, Colab. So with Colab, so it's right now there's no barrier for
Mhm.
learning, right? Now, competition are competition. So your competitors. So this is an ongoing war. I think the trend is to grow bigger as time goes by, and it's unfortunate. I think unless you are lucky, sometimes you see like an entry in a competition in the top 10 that has like a either luck that they just got the right hyperparameters the first time and
Yeah.
they were lucky, right? Because there's thousands of people participating, so luck is going to be given to some of them. Um, so the minimum, if you want to buy right now, I would go with a AMD CPU.
Hmm.
Um, 8 cores would be pretty good
Sure.
because of, especially when you do augmentation.
Hmm.
Um,
Maybe
maybe in the
6 cores
past,
would cut it.
yeah,
Six
or
cores
yeah,
is pretty cheaper compared to 8 cores. That's why.
yeah. The only reason I recommend 8 instead of 6 is because if you down the road want to move to a 2 GPUs, then
Makes
you are
sense.
covered. Yeah, then you are covered. Whereas it will be more expensive, you have to sell and then buy the other one. And then in terms of GPUs, I will get, if you can afford like a 2060
Sure.
NVIDIA, because it has better support for hybrid training,
Mixed
mixed
precision
precision
training.
training,
Sure.
and that makes a difference because you can fit more batches
Definitely.
in memory, and then it goes, in my experience, sometimes with the RTX 2x faster,
Definitely.
and it's just in fast AI one line of code.
Just one function, honestly, not even a line.
Yeah, then one function exactly.
So, as you know, like during a competition, you may be running 20 to 30, maybe even more experiments, or even generally in like a data science scenario. Could you tell us maybe what ideas worked for you and what didn't work during this molecular competition, and some thoughts behind like how did you approach when an experiment failed?
Yeah, I think for us the biggest um, failure in terms of failures, the biggest failure was that um, regularizing the model was super hard.
Okay.
So we tried dropout with both team number one and team number three managed to do successfully, and we couldn't. We also tried adding like rotations, and the transformer already was working great with our rotations, and it didn't add up. So in terms of regularizing the model, our train versus validation. So validation was, almost spot on with the leaderboard, which has many teams.
Mm-hmm.
So in the competition, it was great. But then our train was so much better than validation. So some models we managed to get -6
Okay.
in terms of train loss instead of minus 3.1, 3.16, the best we got. So there was a very clear issue
Mm-hmm.
with regularization that I tried both different, even scaling weight decay didn't work. I tried something I thought I invented, but it was already invented, which is called cutout. Like I didn't know about it. I call it knockout, which in this competition was basically like wiping
Mm-hmm.
random atoms, which in the attention layer. So I did in the attention mask in the transformer, like wiping atoms, like knocking it out. It's called cutout.
Okay.
That didn't work either. So the model, even with that, trained great, good laws, but didn't regularize. Um, so that was, I think, our biggest thing that even today I do
Mhm.
not know why it doesn't work.
Got it.
So that's something I need to look into because obviously could be further improved if we had the right regulation. Yeah, that's the big.
Got it. So the next question is by WJWKA. That's the username on Kaggle. What would be the first idea in your mind about feature selection, and how do you allocate resources when time, for example, being considered when the resources are limited? Kaggle would be the best example.
So I think a feature selection, um, based on this whole conversation, is a pretty moot point because I tried not to do
Yeah.
manually generated features. So I think the answer is shifting. The answer is trying to find the input representation with the most entropy
Hmm.
that could reconstruct the data and has like a very nice matching machine model that you can fit in. So that would
Got it.
be, and in terms of resources, um, I don't know the answer. It depends on each competition, really, what the challenge is. So, but again, it's try not to write too much code and do the computer do its job. That's to me the question would be right now, honestly, do I get a gaming computer or not?
That's a great point. Um, so the next question is by Vikrant. What are the things that help you increase your score gradually, and the strategy you use there? And maybe if you could also summarize your final solution that made it to the second position.
So in terms of gradually increasing, in our case was just a hyperparameter manual search. So in the transformer architecture, you have few things that you can tune: number of layers,
Mhm.
um, the width of the model, number of attention heads, they call it number of heads, and the dimension of the aggregate of heads of the attention. So those are, and we just basically started like trying different things. And I must say that this is an area that we could have done a better job, especially if we had more computing,
Mhm.
because we would have been, especially me, more disciplined um, in testing the models in equal conditions. So you say, okay, I'm going to leave this for like 300 epochs, which is
Sure.
3 days. But then sometimes what happened to me is I got excited. I got this idea of knockout, and what the model was like need training, I would kill it,
Okay.
and then like finish training with knockout was kind of a weird mix. So because of course, if I had like two you know separate resources, I could have trained. At the very last days, I rented in a place that Pavel told me. It's called fast.ai,
They have
and
pretty cheap multi
yeah,
GPU machines, to my surprise.
exactly, super cheap compared to the others. They are a bit less reliable, so they have, of course, this price comes with its thing, but it worked for us. So I could run a few experiments. So I spent. Somebody asked me, so how much did you spend? So I spent maybe like 60, $70, and I rented like two machines with four 2080 Ti's each for
For
the final.
reference, I believe on AWS or maybe GCP, this would easily be above 200, $250.
Yeah. So it's significantly cheaper. Also, but I must say also that for a few hours I tried because preemptive thing they kill it. I tried like an eight V100 machine,
Wow. Okay.
significantly more powerful, and
Yeah.
it was crazily fast. So not
Interesting.
only used, but it was like incredibly fast. But it was super expensive, so I bought you know that you can rent this thing called Preemptive
Yeah.
that is super cheap, but they can shut it down, right?
Hmm.
So my experience with you do this in Amazon, they don't really shut it down this often. But in Google Cloud,
I
I
agree.
was getting like shutdowns every like 2 hours,
Okay.
and then I couldn't use it because you know training. So of maybe if it was like a company, you would be like a fault tolerance system that on each restart you resume training and it's super doable, right? But I didn't have the time, so it was like I think like 3 days before the end competition to do this.
Got it.
It's not difficult really, but you have to do it.
Sure. And if you could maybe give a very high overview of the final solution that made it to the top of the leaderboard.
Yeah. So the final solution. So it's the input representation is just the three coordinates that are given to you in the training set. Just normalized like minus their mean divided by the standard deviation, so that the mean is 0 and the standard deviation is 1, which is you know vanilla normalization, and then you get the atom also and the coupling type, and they
Hmm.
have like 8 types depending on the different atoms. So how do you fit it into the transformer model? So the transformer model has, let's say, 266 and 56 dimensions. So in this vector, the three first is the XYZ, right?
Sure.
And the other is just for the remaining 253
Okay.
dimensions. So it's like an embedding.
Hmm.
It's really an embedding, learned embedding of the atom type, which is you could really encode it in like a one hot vector, right? But because the transformer needs this width, so you expand it into embedding with more dimensions,
Hmm.
which could be, in my mind, um, the if I was a neural network, right? I could. So right now it only knows that this atom type 3, right?
Yep. Yep.
Which we know, let's say, is oxygen, for example, right? But then in this huge vector of 120 something dimensions, it could find or learn like physical characteristics of
Sure.
the atom, right? So,
Yep.
let's give some room for the model to be a good physicist, right?
Hmm.
Uh, and then same for the J coupling dimension. So that's the input, right? So the input is really um, three coordinates and
Okay.
an embedding of the atom and the coupling type. This gets and this really gets into a pretty much vanilla. Although Pavel did some changes on some of his models on the
Hmm.
attention layers, but in mine were just um, vanilla um, transformer encoders.
Hmm.
The decoder is a bit different, so we use the encoder. Um, and then there's like maybe the smaller model was 6 layers, and the biggest one was 24 layers.
Okay.
And then what you get at what you get at the output. So on the output you get so this is like 29, right? So you need to mask them because some of the molecules do not have 29 atoms. So you have the attention mask that you can mask, that you can use for the transformer. Although it's not really needed if you do things a bit differently, but it's better to use the attention mask. The attention mask basically lets you tell the model, hey model, you cannot look at this position.
Okay.
Okay, so it's a way of forbidding the model to look at this position. The mask, right? Then it
Great.
learns the attention, but the mask is to forbid the model. In the language thing, they use it to prevent the model from looking into the future
Got it.
because they
Hmm.
want to predict the future of a sentence. For an embedding, you have to look at the future. Because in theory, you could look at the whole thing. So we only look at the valid atoms. And then the loss function, it's very straightforward. And the only caveat is that because none of the 29 atoms have J coupling defined, it's really masked. So we build a mask of which ones are valid. So the loss function only uses the ones that are valid. That's it.
Got it.
So it's
Hmm.
super simple. And the only thing I'm missing is each at the very end of the, let's say, 24 layers of transformers, you have like the same dimensions as the beginning, right? So what you do is we did um, it's kind of a linear transformation of all the atoms from 256 to either 4 if you use the scalar contributions that were given to you, or just 1 if you want to predict the final scalar contribution. Uh, and if you think about this, it's really like a 1D convolution because it's a linear transform with shared weights because the other doesn't really matter to you.
Makes
So
sense.
it's a convolution in 1 dimension. That's it. Um, and that's it. That's super simple. There's no there's nothing else.
There's no quantum mechanics involved at all.
There's no exactly. I think the number one team they built that transformer model that had priors with quantum mechanics, and it was really sophisticated because it was really a graph. Um, but ours, as you can say, is like super simple. I'm actually really surprised
Yeah.
that that it works so well being so simple.
So the next question is by Rahim Nasiruddin. How can someone develop the good habit of progressing on each competition? I'd also be curious, like what happens once if you're stuck maybe on the public leaderboard and you're out of ideas? What do you do after that?
So I think there's two things. One is to look at the leaderboard, and then I would recommend that when you start, you set your goals. Like, what do you want out of the competition? Right? Do you want to win a medal? Do you want to learn? Right?
Hmm.
It's very different, I think.
Yeah.
And I would recommend, especially if you're starting, to to set your goal learning because I think there's a dark side of gamification,
Gamification.
which is some people sorry the gamification thing just to team up to win medals and you don't learn.
Yeah.
So my recommendation is okay, do as much as stuff as you can personally. So
Hmm.
look at kernels, get ideas, but then code them yourself because each mistake is not a mistake, it's a learning experience. So
Definitely.
that's pretty good. And then not especially not focus so much at winning or not winning. It's extremely competitive, and and then if you're stuck, team up. That would be I think the best approach. But I would also recommend to team up with maybe just one team member only, because if you team up in a big team, you
Hmm.
could be tempted to not do anything
Yeah,
or to do less that you would do if you were to do it with just two.
that's a great
Um,
point.
so I've seen, so I've teamed up a few times, and so my experience has been a big mix with Pavel. Every time we've teamed up, it's been a great experience. With other people I've teamed up, sometimes it has been good. Like for example, in the data, this big data, what is it called? They do it once a year about
Data
data
science pool?
science. Yeah, I think the DSP
DSB.
or DSB. So this one was pretty good, but then there's been others that I've teamed up, and his team will tell me that they have a great solution, but they didn't do anything, like
Okay.
anything, right? Nothing. So it happens, right? So it's this is really a game, but then again, it's a big team. So if it was a person only, kind of the responsibility is more is more defined than
Hmm.
being a scholar. At least has been my experience, right? And the reason I said I like to team up is because you get wildly different perspectives.
Got it.
So some may be good in finding leaks, right?
Yeah.
Which I don't, I don't really explore at the
Hmm.
beginning. But sometimes you don't find a leak, but looking at finding leaks, you find something that could be super interesting. I'm going to give you an example. So when we started the Airbus competition about the ships that Pavel found this leak, we're initially looking at something different. What we were trying to do was to um, assemble like a big map, like they give you small tiles, and
Right.
we knew that we could put the tiles together, right, to build like a
Yes.
build map, and then we could do better augmentations, right, once you have this big map.
Mm-hmm.
But then what we found, what actually found was that the tiles were overlapped, and that really was a crazy because in test and train, and
Yeah.
that was the leak, right? So although we were not looking for the leak directly,
You found
indirectly,
it.
right? And that's a different way of thinking, right? Which maybe I would have not even thought that we were given the data in the state that we were given.
Sure.
And it's a bit sad, right? Because we did this, and then they have to cancel the competition, get the new data, and redo it. But then like we lost interest, and then we didn't even do it. Like, kind of our job here is done, right? Situation. So yeah, that was fun.
What best advice would you have for someone maybe who's just starting on Kaggle to just learn?
So what I said is try to do it yourself, even if you
Mhm.
fail. Um, don't don't get obsessed with the rankings or the leaderboard, because it's like super competitive and initially you just want to learn.
Mhm.
And if you see stories about even the Kaggle Masters, you know, some of them, they when they started, they got pretty bad results.
Yep.
So that's normal. There's people that think, okay, I'm frustrated because I'm seeing all these great solutions, and I fear that I may not be up to the task. Everybody, we all start like that. And then, like what I said, team up initially, especially initially, team up with few team members. So you actively have to work, because otherwise it's like too asymmetric. Um, and the third is to read in depth solutions for competitions. It's much better if you have participated, because you know
Yeah.
firsthand what you're dealing with. But even in competitions that you have not,
Hmm.
because you may see like a new keyword to you. Like, for example, I remember in the Carvana competition, because I
Yeah.
just like my first Kaggle one, the top team used like what they call like level 2 and level 3 ensembles, like
Yeah.
stacking. I had no idea what that meant. Like a boosting, what is boosting? Like I thought it was like a library, or like a deep learning architecture, which I didn't know about. So
Okay.
even like reading the solutions may will give you pointers to
Mhm.
different stuff.
Got it. The next question is by Rahim. How can African guys also have a breakthrough when dealing with Kaggle Grandmaster? Which I'd like to reframe as how's the, if you may elaborate on that, machine learning scene in Spain, and just to elaborate on the fact that most of the online learning for you, I believe, comes from Kaggle and online resources, not just the local community.
Right. So addressing the Africa thing. So there's of course I don't really have direct experience in Africa, but I would point the person posing the question to two resources. One of them is there's a community and a conference called Deep Learning in Dava,
Yeah.
um, which if you are in Africa may be worth to look at. And the other is in the Fast AI forums. There's a study group for Africa. So that's started for our community in Spain. So again, most of my stuff. Actually, there was one thing that I did that I
Yeah.
haven't mentioned, which is in terms of I think the only time I've learned like physically being in a place to learn deep learning was in I went to a summer school. When was this? In 2017. Yeah, like 1 week summer school in Spain in Bilbao,
Okay.
which was amazing. Like first 1 week, first best like 1 week learning experience ever. Because especially it was there were people coming from the Vector Institute in
Hmm.
Canada, people from Facebook, from Google, from Microsoft. So it was great, great people, um, giving all the talks.
Interesting.
Um, so that was, and there's lots of good summer schools for deep learning in many
Yep.
places. So time This was in Europe, so this time this specific one took place in, I think, Warsaw in
Mm-hmm.
Poland. But there's few in Canada. In the US, there's, I guess, a bunch. And
Yep.
in Asia, I don't have the luxury of speaking any of their language, so I don't really know. Um, but I'm sure there's a bunch in China and maybe in Japan and Korea. And then in terms of global community, in in, uh, in Spain we have two, I think, two big communities in terms of Slack groups. One of them is called MLH, like Machine Learning Hispano, which also
Okay.
includes not only Spain but every Spanish-speaking country, especially in Latin America. And the other is Machine Learning Spain, Spain Machine Learning, if I remember correctly, and those run through Slack. Um,
Okay.
in my city, there's no really um, in terms of like a community. There's my university, not the university I studied in a different university, but the
Mm-hmm.
university in my city in Alicante, they their postdocs and PhD students, they run every 2 weeks one like a meeting which is open, and also we do in my city, we organize um, like a conference more geared towards the general public. So it's
Got it.
not really but it's pretty good because I think there's one thing that is missing. So right now, you and I are discussing the how, right? How we do things in
Yep.
machine learning. But I think the bigger question is the what and the why. What do we
Sure.
want to do with AI and machine learning, and why do we want to do it?
That's a great
Um,
point.
and then this, I think, is going under the radar. I think we do have some responsibility as practitioners to educate, because I think the worst thing that can happen is to have people who have no idea what they're talking about to either regulate
Yeah.
AI or speak about the Terminator scenarios and crazy things like, yeah, that's crazy, right?
That's a
So I
great
think
point.
we do have some responsibility
For sure.
on in terms of um, trying to have the society understand. I think the best example, at least I've seen, is in Finland, where
Mm.
they have like a general for everybody, um, like a training, open training on what AI can do,
Mm.
what are the implications, what is the difference between the ethics, what they call ethics, right? The bias, um, the I don't know if it goes this far into, which I think is the key issue, into correlation, which is what we
Yep.
are doing every day, and causality, which we are not doing. And people think we are doing causality, and
Mm.
we are not. So that's a big issue. So those are things that I don't think, as far as we don't have, our community in Spain is about the how at this point. So it's engineers that want to learn, etc. I think we are missing a big opportunity in Spain and maybe even beyond Spain
Yeah.
about having people who really know what you're talking about, like Rachel Thomas and others that have this higher dialogue and why we want to do it and what we want to do.
That's a great point. I think also, like you said, what many people miss out is I'm just doing a Kaggle competition. How will this even affect ethics, or how will this even matter? But people generally even overlook things there, and things like that, in my opinion, also adds to the origin of all of these biases.
Yeah, well, there's for example, there's one competition that I didn't join specifically because I wasn't really aligned with their goals.
Hmm.
Which this may be weird, but I'm not the only one I know because it was posted in the forum. Which is I think it was called the TES salt segmentation.
Yeah,
So remember, there's this
I do.
like graphs about salt, which may some innocuous, right? Like yeah, we have to segment salt, right? But what was the purpose of this competition? So it
Yeah.
was about drilling oil, right?
Hmm.
So in my case, everybody is free to think, what they want to think. But in my case, I didn't want my code or solution to be used in a project that, at least as far as I understand, maybe I'm wrong, would go against, would make climate change worse because oil extraction. So I would rather work in a solution that address climate change instead of helping. The most extreme case is like helping like a tobacco company become, use machine learning to have people be more addicted, right? So that is like bad, right? I don't want to work on that, on creating
I really
addictions.
respect that perspective.
So maybe, I down in that scale the
Yeah,
salt competition, but I didn't want to join. So that's a good point. Although it looked like a nice competition because it had some challenges, I didn't want to join this one. So that's I think you're we are missing maybe, some perspectives, in terms of, being, be taking more ownership on the side effects or on the effects, right? Not even side effects, on the effects
sure.
of these technologies. I think we have, as engineers, we have to, at least both take more responsibility and educate people on limitations and risks.
I really respect that perspective. So this conversation has really been full of many great advices. So thank you for those. My final question would be, what single best advice would you have for someone who's just starting their journey into machine learning?
So, few things. Don't be overwhelmed because, especially today, like every week is like as if the whole thing is being rebuilt every week. Like classification, like before you only had like VG and that was the best, right? Then ResNets, then X ResNets, then Y ResNets, then what else, right? I'm losing track, right,
Yeah,
of things. It's impossible to keep track of things. Many of those, so you have to remember, like many of those are very incremental improvements. So don't be overwhelmed. Um, and then I would recommend in terms of learning, like have some training in the form of online free courses.
mhm,
If you are not such a self-taught, self-taught student, maybe you opt for paid courses which have projects, which
mhm.
is also a great experience. Maybe if you live, you have the opportunity to have in-person, so do like regular learning, but then take them into practice. And right now, the single best practice before like going into a company is to take part in competition because you get, many angles, and it's the closest you will get to a real setting. And then use the advice that, my advice that also you've done interviews with great Kagglers, and they also share great advice. So read all your interviews and their advice.
Thanks for the mention. We'll definitely have the series linked for those who want to check it out. Maybe for courses, I'd also like to mention fast.ai. It's my personal favorite and the only course I'd recommend. So if you'd like to spend some money, what I'd suggest is go there in person, have use that study group over there. I know it's pretty intense during those weeks. Maybe give that a shot, but definitely check out fast AI for a course.
Yes, I would. Yeah, I'm with you. I would recommend. So I would recommend two things with Fast AI. Was one is first Fast AI, and if you have to ask me for a second one,
Mm-hmm.
I would do the CS. It was 2319, right?
Two three
The
one
one,
N. Yeah.
yeah, they stand for the one that Carpathy did in 2016. Although it may seem to you that it's like the Middle Ages, even the speed that we are, but that one is completely different from fast.ai in many respects. But if you once you've done fast AI and you want to dig, have a different perspective,
Yep.
it's pretty different. It's an incredible, valuable resource.
Got it. So this has been an amazing conversation. Before we end the call, what would be the best platforms to follow you and follow your work, apart from Kaggle, of course?
Um, I think I'm most active on Twitter. with the caveat that I usually tweet in Spanish. And the reason is because I really want to be an influence to have people jump from software 2.0 to software 2.0 in Spain, which we don't have many people talking about AI.
Yep.
But even if I tweet in Spanish, I have to say that I also follow like Japanese Kagglers that tweet in Japanese, and there's a single button to translate tweets. So you can follow what I say, and with that, it's built in Twitter. Translate tweet, you will get it in your local language.
Translate works well for you. So while I was searching your profile, it worked well on your tweet. So please don't let that barricade you from.
Yeah.
All right. Thank you so much, Anders, for doing this interview, and thank you for sharing all of these great advices today.
Okay, it's been a pleasure, and thank you so much for both for inviting me and both for putting this together. I think it's a great resource to have like a peek in. I was reading some of the interviews that you've made, and those are great.
Thank you so much. It's all great
Okay,
because of people like you who agree to do them. So thanks to all people like you.
okay, you're welcome.
Thank you so much for listening to this episode. If you enjoyed the show, please be sure to give it a review or feel free to shoot me a message. You can find all of the social media links in the description. If you like the show, please subscribe and tune in each week to Chai Time Data Science.